Hello and welcome to this video session on designing push-down automata for the given language a to the power n, b to the power n such that n greater than or equal to 1. The language is n equal to a to the power n, b to the power n such that n greater than or equal to 1 and will be try to understand how PDA can be designed for the language n equal to a to the power n, b to the power n such that n greater than or equal to 1. Now, possible strings can be AB, AABB, AAABBB and so on. Now let us take one string as an example. Let it be this string, that is W equal to AAABBB. Okay. And as we know that PDA makes use of stack as its internal memory. So how it deals with this is there is an epsilon here, end of the string. So when it encounters A, first symbol, it pushes it onto the stack. And as a stack empty marker, basically there will be a symbol that is Z0, which is at the very bottommost of the stack. So when it encounters A, it pushes it onto the stack. Then when it encounters second A, once again it pushes onto the stack. When it encounters third A, it again pushes it onto the stack. This time it is coming across another symbol B. Now all these operations it performs in state Q0, that is the starting state. And now when it encounters a different symbol B, it changes its state and it starts popping the topmost element from the stack. So when it encounters this B, it pops A. It encounters the next B, pops once again the A. It encounters the next B, pops again. Then it encounters or comes across epsilon symbol, that means string has been exhausted, all the symbols have been read, and it sees a Z0 here, which is nothing but indication of empty stack. Now, PDA accepts string on two conditions. So PDA's acceptance will be accept by final stage or final state, PDA acceptance by empty stack. So either of the options will hold. PDA acceptance by final state, PDA acceptance by empty stack. And here the PDA acceptance is by empty stack. Now let us see how state transition diagram can be built, can be designed. Okay. That is, it starts with Q0. Okay. On Q0, the symbol read will be A, okay, and on top of the stack, initially there will be Z0, no symbols. What it does, it pushes that A onto the stack. So this is how the things go. It is W. So initially, no symbol, Z0, and sometimes there will be symbols already pushed A's, okay. In that case, if it reads an A, on the top of the stack there is an A, it pushes that onto the stack. Now when all the A's are pushed onto the stack, now there comes the turn for dealing with B. So when it encounters a B, it changes the state and it moves to state Q1. That is, symbol read is B. On the top of the stack there is an A, and that A is popped. And to show the pop operation, epsilon symbol is used. Okay. Next, it stays on the state Q1 and it reads the rest of the B's and it pops whatever the A's it has in the stack in a loop. Now once all the symbols have been popped from the stack, okay, now it encounters an epsilon On the top of the stack there will be Z0, okay, and it leaves that Z0 as it is, and it moves to Q2, where Q2 is the final state. And this is a PDA transition diagram for the given string AAA, BBB over the language set A to the power n, B to the power n, such that n greater than or equal to 1. Now this is first part of your answer, that is transition diagram. Now second part of your answer will be transition functions. So that let us see. I will put it over here. Transition function. Okay. Transition functions can be written like this, that is delta of Q0, symbol read is A, and on the top of the stack there is Z0, which gives rise to Q0 A Z0. That is, whatever the symbol is read, this is the syntax or notation, whatever the symbol is read, it will be pushed onto the stack, showing the stack top and the pushed symbol as the indication. Next, on the same state Q0, A is read, but on the top of the stack there is already an A, that we show it like this, A. Symbol read is A, already there is a A on the top of the stack, and it is Q0, AA, that is stack top and the pushed symbol. Next, on the same state Q0, if a B is read and on the top of the stack there is an A, then what we do is the PDA will move to Q1, state Q1, and one A will be popped, that is epsilon. Now on Q1 there can be several B's that it encounters, so all that will be popped. Now on Q1, if it comes across a symbol, I mean epsilon, where the stack of the top is Z0, this gives rise to its final, it is transitioned to final state and keeps Z0 as it is. So this is the transition functions for the given designed PDA. Now the third part of your answer is instantaneous description, that I will show here. Okay, for the same string there is AAA, BBB. So it is instantaneous description. It is abbreviated as ID. Okay, and it is Q0. We have the symbol, we have the string A, B, and top of the stack is Z0. And to show instantaneous description, we use this symbol. Okay. Now from this state to the next, this transition to the next transition, it is first A will be read, and the PDA will be in the same state Q0. So A will be read. Remaining is A, B, and on the top of the stack we have A and Z0. Next, one more A will be read, and the PDA will be the same state, and remaining symbols will be A, B, and on the top of the stack or in the stack there are these contents. So while writing instantaneous description, we are supposed to write the entire thing which is present in the stack at that moment of time. Next, in state Q0, it reads one more A and the remaining content is B, so it is A, Z0. Next, on the same state Q0, when it reads a B, okay, remaining state symbols are B, one A is popped, that is A, Z0. Then it continues. Okay, so it moves to Q1. It moves to Q1. Okay, then in Q1, once again it reads another B. Remaining is this B, and it pops one more A from the stack. Now, on the same state Q1, it reads one more B, and remaining is epsilon. and what remains is Z0. Now from this state, when it reads epsilon and top of the stack is Z0, it reaches to final state, maybe Q2 or QF, okay, with Z0. And this is the instantaneous description for the PDA design for the language a to the power n, b to the power for all n greater than or equal to 1. I hope you understood the explanation.